This is Irv Shapiro with the Dr. Vax channel. And today we're going to help you make one of the many decisions you need to make when you're beginning to use a 3D printer. And that is, what filament should you buy? If you've used a 3D printer for a long time, what filament should you use for a particular model? Should you use PLA or PETG or ABS or ASA or Co-Polyester? Or maybe nylon? Can you even print with nylon in your printer? And then you have companies like ColorFab that name their filaments completely differently. ColorFab XT, used to print this semi-clear vase. It's a beautiful filament. What is it? So today we're going to help you answer those questions. Whether you're printing a dragon or you're printing a phone case, what should you be using as your filament? Stay tuned and let's learn something together. Now, before we start talking about the individual materials, PLA, PETG, others, let's talk about what you see on a website when you go to buy filament. And most people today buy their filament online. So let's look at this picture together. What you see here is it starts with color. That's obvious. However, each company is going to have slightly different names, and they may have prefixes on the name. They may say it's a silk filament. Silk filaments tend to be rather shiny. This is a silk gold from CC3 China, one of my favorite filaments. The color may be rated with a standard color grade. Most aren't, but it's possible. And in fact, unfortunately, the picture on the website may not look exactly like the filament color. So the only way to really know precisely the color is to have a sample or buy some of that filament. Next, we're going to look at diameter. Diameter is most often 1.75 or 2.85. Now, some filament manufacturers list the 2.85 as 3, and it makes a difference. So the only way to know for sure, once again, is to measure it yourself, and you would use a caliper to do that. When you first use a caliper, you turn it on, make sure you hit the button that says 0 so that you've reset it so it's 0. And then you can see in a close-up picture, this happens to measure right here, 1.72. However, if I measure it somewhere else, now it's 1.71. And down here, it's 1.69. So what's going on? Well, you pay for precision. Filaments in general that have a closer diameter tolerance are more expensive. Most of the filament sold today is pretty good, and it ranges from a tolerance of 0.05 to 0.02. Why does that matter? Well, when you're extruding filament, the variation in the diameter will cause a variation in the amount of filament that's extruded. If the variation is too wide, you'll get under extrusion or over extrusion. One of the things that I find very interesting is that people generally seem to want to print at the smallest possible layer height. I want to print at the largest layer height that's acceptable for that print. You know, if I'm making a bracket that no one's going to see, I don't really care that it's ugly. If I'm making a piece of jewelry or something with fine lettering that people are going to see, maybe I'll print it at 0.15 or 0.10. So layer height matters, and the diameter tolerance of the filament will impact the quality of your layers. Next, let's look what we have here. You'll have a recommended printing temperature and recommended printing speed. Now, those are guidelines. I very often print above the recommended printing temperature. if in particular I'm using a large nozzle or I want to print very fast. Why? When you want to print very fast, your filament has less time in the melt zone of your hot end. So if you set the overall temperature hotter, you're more likely to completely melt that filament. You'll then have another parameter that's not shown in this example, but that's the glass transition temperature. It's basically, and this is an oversimplification, I apologize to the chemists and the material scientists, but it's basically the temperature it starts to get soft, pliable. That's important because if you're going to leave your filament in the car and the car's going to get up to 120 degrees in the sun, you don't want your coat bracket over the back seat to begin bending down and drop your coat on the floor. So you need to understand glass transition temperature. Generally, if the print temperature is higher, the glass transition temperature will be higher. Next, you'll see the weight and the diameter of the spool. In general, many spools have 1 kilogram approximately of filament, and the spools generally weigh about 250 grams. Why is it important? If you weigh your filament spool before you go to print and you subtract 250 grams, or you know exactly how much an empty filament spool weighs, then you can compare that against your slicer parameters and determine whether you have enough filament left to print. And finally, you'll see something called shore hardness. That's basically how flexible is your filament. So some filaments, this happens to be a filament called PLA, and PLA is not really very flexible. Yes, you can bend it, but if you bend it too far, it will crack or break. On the other hand, this filament here is TPU, and it's very, very flexible. Now, there's an even more flexible filament called Ninja Flex, which is really flexible. So the shore hardness is important. There's an inverse relationship, however. The more flexible your filament, the harder it is to print with. Why? Because you have a couple gears that are loading your filament into your extruder. Maybe they're loading it through a long tube, through a Bowden tube. Maybe the gears are directly on top of the extruder, a direct extruder printer. But the more distance between those gears and your print mechanism, the more likely that flexible filament will get compressed or stretched. The more likely that flexible filament will flow outside of the correct path. If you have a gear and then you have your Bowden tube and there's a big gap there, that filament might end up outside your Bowden tube. So flexible filament is much harder to print with. It also impacts dramatically retraction settings. So shore hardness is important. Next, when you buy filament, what do you get? Well, generally you get a box. Most often it looks like this, not always. Sometimes it just comes in a bag. Inside, almost every single time, you'll see your filament in a plastic bag that has had all the air sucked out of it. Now this one I already opened. What's unique about CC3 China is they actually give you resealable bags, which is really very, very nice. And then the next thing you're going to want to look at is how well the winding is on the reel. The more uniform the winding, the less likely your filament will jam when it goes to pull it off the reel. In a reel where the winding is terrible, you're likely to get more jams, which is why every single time you're done using your filament, you need to stick it back into the holes on the side of the reel and pull it tight, even though you're going to waste a little filament, so it stays in a nice wind. Many filaments will absorb moisture from the air, so you want to keep these either in a sealed bag or a sealed container, or potentially even a sealed container of some type of dehumidifier in it. let's take a look for a minute at this table of filaments. We're going to cover PLA, ABS, PETG, TPU, Co-Polyester, nylon, and filled filaments. And I'm going to look at some examples and talk about the characteristics. So let's begin with PLA. If you don't know what filament to use PLA. It's by far the easiest filament there is to use. Many of the samples up here were printed in PLA. And interestingly, PLA is in fact one of the strongest filaments you can print with. Now, PLA is not very flexible. In fact, depending on the PLA, when you take and you go to bend it, it may crack. This happens to be Hatchbox PLA, which is not too bad. It is a little bit flexible. The less flexible it is, the more brittle it is, the more likely it will snap. So PLA tends to be very strong, but when it gets to its breaking point, it just snaps instead of bends. On the other extreme, you'll have a filament like nylon, which is not actually quite as strong as PLA, but it's very flexible. So it tends to bend instead of snapping. PLA generally prints at about 180 degrees, 200 degrees. I often print it at 206 degrees. It can be printed either in a fully enclosed printer or an open printer. If it's a fully enclosed printer and the fans on the extruder and hot end are not excellent, the PLA will actually stay too warm and you'll have difficulty with it. So you'll have to open the doors. So if you're using a fully enclosed printer with PLA, make sure you have great fans in that printer or just open the doors. So PLA should be, in general, your go-to filament. It's by far the easiest to print with. The next filament, ABS, and by the way, I'm not even going to attempt to give you the long chemical names for each of these filaments. Most people, at least in the hobbyist industry, just refer to them by their acronyms. ABS, and I don't have a sample of ABS here because I don't generally print with it. ABS, unlike PLA, gives off fumes when you print with it. PLA does not give off fumes, or not significant fumes. PLA is made from biostock, made from very often corn. It's biodegradable. ABS is sort of nasty plastic. However, in its solid form, it's safe. But when you melt it, it's a little more volatile. ABS is used in common toys such as Legos. And the reason a lot of things are made out of ABS is it requires a relatively high temperature to print. Let's look at our table. ABS prints at about 215 to 240 degrees Celsius. That compares to about 180 to 210 for PLA. The glass transition temperature is almost double. And that's why ABS is a good material to use if you're going to use it for something in a closed car in a warm climate. However, because of the fumes and because it requires that you keep it at a relatively high temperature while you're printing it, otherwise it will start to shrink a bit and that will cause it to warp, you almost always have to print ABS in an enclosed printer. So if you don't have an enclosed printer, you can print ABS, but the more consistent you keep the temperature, the better it'll be. So ABS might be the most difficult, or almost the most difficult, nylon's pretty difficult too, material to print with on this chart. In addition, the next filament listed on the table, let's look at it now, PETG, is a wonderful replacement for ABS in many settings. So my go-to filaments are PLA and PETG. You'll see here that PETG prints a little bit hotter, but it prints under 250 degrees Celsius. Many consumer-grade printers have a limit of 250 degrees Celsius, and therefore PETG is still a good choice. It does require a heated print bed. In fact, PLA, that easy-to-use filament, does not. you put a little glue stick or magic glue on your print bed, you can print without a heated print bed. PETG does require a heated print bed. It's a little more sensitive to environmental temperatures. And in fact, you have to be careful because it will stick to the print bed really well. And so very often I will rub a little Windex on my print bed before I use PETG. That helps it to release because it leaves a thin film of soap on the print bed. It is not quite as strong in strength tests I've done as PLA. It's almost as good, but it's much more flexible. So for many environments, it will seem stronger because if you just go to pull on PLA, it'll hold more weight. But if you go to bend it and flex it, it will more likely, because it's brittle, snap before PETG will. Now the next filament we're going to talk about is TPU. TPU is used when you want to print things that are flexible. Most phone cases are made out of TPU. As I shared before, the flexibility rating of TPU is called shore hardness. Let's look at this table and you'll get an idea of shore hardness. So gummy bears are really flexible. They would be on the far left of this table. Shore hardness has 3 different scales, 0, 0, A, and D. And we're generally printing with materials in the A scale that are between about 80 and 100. So we're printing with materials in a relatively narrow range. TPU will range from around 80 to 90, and the harder TPUs are easier to print. So I'm a big fan of SaneSmart TPU because I find it really pretty easy to print. It's still pretty flexible. A lot of people like NinjaFlex. It's a brand name. It's extremely flexible. This was printed in NinjaFlex, and it's just like almost like a rubber band. Whereas these were printed in SaneSmart TPU, and they're flexible, but they're clearly firmer. So TPU is the go-to filament if you want flexibility. Now there are new filaments, such as Matter Hackers has a new filament I haven't tried yet called Soft PLA. These are PLAs which are easier to print, which have been modified to make them more flexible. I'm looking forward to trying Soft PLA for a phone case, because if you print a phone case out of traditional PLA, this one actually was printed out of PLA, and you'll see the picture here, you can't get the phone in because you can't bend it at all to slide the phone in. So I'm going to try Soft PLA to see if that'll be printable on a wider range of printers. The general rule is soft TPUs can only be printed on direct extruder printers. Now that's not universally true, but it's easier to print soft TPUs on direct extruder printers. Next, let's talk about copolyesters. Copolyesters are more complex plastics. They often look like some of the plastics we see every day, and they have often unique characteristics. So this happens to be ColorFab XT, which is a copolyester, and you'll notice it's really pretty clear. I think this is a wonderful, wonderful material, but it does print a little hotter. I often print this at somewhere between 240 and 260 degrees Celsius. Now that also means that its glass transition temperature is going to be a little hotter. So if we look at the temperature here, it's at 75. That's 50% hotter than PLA. It is good strength, but it is only a little bit flexible. A little more flexible than PLA, not as brittle, but it is good strength. And I like to use it for specialty items, such as semi-clear vases. Next on the list is nylon. Now, nylon requires a heated print bed that can get to a relatively high temperature, about 70 C or higher. It prints at a very high temperature. So it generally prints at about 250 to 270 degrees Celsius. That means many printers in the consumer area cannot print that. I only have one printer that can print at those temperatures reliably and safely, and that's my Prusa i3 Mk3. Finally, let's talk about some very interesting filaments. Filaments where they combine a thermoplastic, a plastic that can melt, with a non-plastic. So this is ColorFab wood fill. And literally when you take and print with this, it smells like burning lumber. Filled materials generally are more abrasive to the nozzle on your hot end. And therefore you often will use a hardened steel nozzle. I actually have a ruby nozzle in my Prusa for printing filled filaments. Now, wood fill is not very abrasive, but it is a little tricky to print with. In general, you have to print slower with filled filaments, and you have to fine-tune the temperature settings to get them just right. When you do, you produce beautiful things. So this is a bread knife. This is a wood fill handle that I then stained with traditional wood stain. It's beautiful. It's beautiful. This one is even more interesting. So this was printed with ColorFab bronze fill. It's really heavy. It feels like bronze. And then I buffed it on a buffing wheel like you would buff bronze. So filled filaments are very, very interesting. They're also used to add strength. So they're carbon fiber filled filaments. They're glass filled filaments. So filled filaments are really on the new bleeding edge of filament chemistry. And I think you're going to see combinations of thermoplastics and a wide range of materials producing unique materials that can be printed on an FDM printer. Let's go back to our table and wrap up. PLA, that should be your go-to filament. It's by far the easiest to print with. ABS, I don't recommend printing with ABS at all unless you're in a well-ventilated area and you have a fully enclosed printer. So if you have a industrial use for ABS where you need the high glass transition point, great. Otherwise, I don't recommend it. If you need a higher glass transition point than PLA, I recommend PETG. It is almost as easy to print with as PLA. However, it will stick to your print bed really well, so I recommend a little Windex on the print bed before you print with it. TPU is the generic plastic behind many flexible filaments. Co-polyesters are often unique materials. I like to use the ColorFab XT material for printing vases. Nylon is really strong because it's wear resistant. It may not actually be as strong in brute strength as PLA, but it's extremely strong because it's wear resistant, it's not brittle, and it has a low friction coefficient. That means it's very slippery and smooth. And then filled filaments are just very, very interesting. So go-to filament, PLA. The next filament for things that need higher temperatures, PETG. Everything else is pretty much a special case, in my opinion. Well, folks, I hope this was useful and got you started along the journey. I encourage you to experiment with filaments, except for maybe ABS, unless you have a well-ventilated environment. And if you did learn something today, give me a thumbs up, subscribe to the channel. More importantly, post links to this video everywhere you can think of. Help me grow this channel so we can do even more exciting videos where we continue to learn things together.